Welcome to the shop. Today we have a vintage half-inch Milwaukee drill, all original from 1960-ish, except for this plastic handle, which it would have came with probably a knurled steel or aluminum handle on there, but somebody along the line upgraded it. Today we're going to take this thing apart, show you how it works, and in the process we're going to show you how to diagnose a few simple problems that you may come across with a non-working drill. A quick way to test to see if you either have a bad cord or a bad trigger, grab your voltmeter, check the resistance. Hook your leads up to the plug. Fuck, I lost my little roach clip here. So we'll hook up the meter to the plug end here. Normally with a good cord and a good switch, you're going to get, depending on the size of the contacts and the size of the cable here, you're going to get 5 to 10 ohms of resistance. If you got a bad cable or a blown switch, you may get infinite resistance, or it may be really high, like in the hundreds, 500, something like that, then you know you got a bad one. So to check in one shot to see if you got a good cord and a good trigger, just hook it up here. And pull the trigger. So here we got 5.5 ohms of resistance. So now you know this whole circuit is good. Quick diagnostic test comes in handy when you pull the trigger and nothing happens. As you know, this is all aluminum casing here. There's no plastic on this thing whatsoever, which makes it quite a bit heavier than a modern drill, but it's just something you don't see anymore. Pretty fucking cool. Start off by taking the screws out near the switch assembly. Basically in here you got your power coming in and your switch assembly that's going to send power to the brushes. Pop this cover off. Now inside here, power goes in here. Contacts closing the switch, sends power to the brushes on the commutator. Now, as you see here, the switch is actually screwed into the body. Normally they're just set in there, and the clamshell holds everything together. You don't see stuff made like this anymore where everything's attached to the body. So we'll pop this screw out. As you can see here, the switch is shielded by what appears to be fish paper, something of like some thick cardstock. So we'll pop this out. Oh, you fucker. This is a really heavy duty switch. Unwrap this. Each one has its own screw-in type connector here. Brass plated contacts. This will be the dead man switch. Hold it in so you don't have to hold the trigger down. This is a really crappy repair that I made here. as you can see, when I bought this drill, there was a short in this wire, and I just patched it together real quick. When I took this drill home after I bought it, I did a little bit of research on it and realized that all these parts are obsolete. You cannot get any parts for this thing, with the exception of possibly the Jacobs chuck and the brushes. But if your trigger went out, or you got a bad armature or windings, you're pretty much fucked, because this drill is so old that everything's obsolete. You just cannot get parts for this thing, which makes it kind of cool and unique. But at the same time, if something shits the bed, it's pretty much a paperweight at that point. So here we got the switch assembly, and basically what that does is that's going to run power to the brushes. Pop out a brush here. The brushes are seated in brass contacts in here. The brush, basically what that does is that takes the power, rides on the commutator here, one on each side. Sometimes the brushes are situated at 180 degrees opposite side. Sometimes they're at a 90, where you'll have one here and one here. Newer higher amperage power tools will actually have 4 brushes. This one has 2. So as you can see, this is a brand new brush here. A lot of times when a drill's not working properly, it's going to be this dingus here. The brushes, they'll either be worn down to a nub, or part of it will actually be blown off. I've seen that before, where it looked like it just literally fucking exploded, and eliminates contact, and you either get a lot of sparks shooting out, or the drill is just dead. So if you're having problems and you tested the trigger cord assembly, your next step would be to take a look at the brushes. So we'll pop this other one out here. Set these aside. Now we'll take the rest of the casing off here. These screws here shoot all the way through and hold the casing on that covers the armature. So we're gonna remove these screws here. Take a look inside. If it's your first time ever taking apart a power tool and you don't really know what you're doing, it's a good idea to videotape it if you can. That way you know how things go back together. This ain't exactly a real complicated piece of equipment, but if you're a first timer, it's always a good idea to have some documentation on how shit goes back together, especially when you're talking 120 volts. Yeah, nice fucking zap. We'll just pry this casing off here carefully without wrecking the fan blade. Sometimes you gotta persuade it with the pry bar. Slide this off here. There. So here's the armature. And the commutator here, this is the part that the brushes run on here. This would be the back bearing. It rides right inside this housing here. Got your field windings in here with your magnets. So basically, power goes in through the trigger, the brushes, electrifies the commutator, and makes her spin. Now inside here is the gearbox. So this is not, for every turn that this armature makes doesn't equal one turn for the chuck. It's gear reduced for torque. Generally they spin at 3 to 4 times faster than the chuck. I think this is rated at a no load speed of about 560. So this is probably spinning at 3,000 RPMs, somewhere in that range. Now inside here, you can take these windings out too. These are just held in by 2 screws. So we'll pop those out. Show you what that looks like inside here. As you can see, over the years, grease from the gearbox, grease and just shit from the air and whatever accumulates inside here. It's always a good idea. And if you're gonna tear this down, maybe wipe out the inside of it before you put it all back together. So we're gonna take this out, inspect the windings. Sometimes these slide out real easy, sometimes takes just a little bit of persuasion. I had these taken apart already, so shouldn't be that difficult to slide out. But you want to be careful though, because the wires, there are wires that are attached to the windings here. So when you're sliding this out, you want to make sure that there's enough slack in these wires. You don't rip one of these out. Like I said, sometimes this takes a little bit of persuasion to get out. And yeah, see this one, we don't have enough slack to pull these windings out, so we're just not gonna do that, I guess. Kind of sucks, but you get the point of what it looks like. So we'll just slide these screws back in here for now. Now, on the armature here, you'll see some drill marks here, here. That's how they balance these things. Sometimes in modern drills, they'll put little weights here in between the gaps, or strips of epoxy between there. But back then they actually took a drill and balanced it that way. It took some material off of there, because when it's spinning that fast, you absolutely need it to be balanced, or you're just gonna shred the fuck out of these bearings here, front and back. Pop that open. Here's the gearbox assembly. Whole bunch of grease in here. Looks like somebody was in there recently and just dumped the grease in there. But here you can see the gear ratio here, where you got this little one. This is the motor, and then that small gear is turning this big one. And then you have another one on the end of here that's connected to that bigger gear inside there, and that's what turns the chuck. So there's a lot of gear reduction going on here, again, for torque. So basically, pretty simple gearbox. There's just a just a shitload of grease in here. Probably a little too much. But you'll have a bearing on the end of this shaft here inside, which the Jacobs chuck rides on. So we'll pop this back together. Let's see how the fuck does that go. There, just like that. And you can see here also the way they focus, you fuck. Come on, focus. Well, anyway, on this cooling fan here, they also did a balance with a drill. Shot a couple holes in there to make sure that was balanced too. You'll see that in any parts that rotate at a high RPM. It's imperative that they're balanced. Like I said, otherwise shit gets ripped apart pretty fast. So basically that's the guts of a drill. Pretty simple. Not all that difficult. In another video, what I'm going to do is I'm going to take a modern drill, maybe this DeWalt here. We'll take this one apart and compare the construction and materials from what they did in the past to what they do now. Obviously, they cut a lot of costs with materials. It would be very, very expensive to make a drill out of all aluminum casing. Now they use mostly glass fiber reinforced nylon and stuff like that, which is durable and strong, lightweight. Now when you're reassembling something like this, it's very important that you don't get any wires pinched putting the case or the clamshell back together. That's probably what happened here. This repair that I had to make is that wire got pinched when somebody took it apart for whatever reason, and when they tightened it down, it pretty much broke that wire, which is extremely dangerous on a tool like this because obviously aluminum is a good conductor of electricity. And when you're fucking around with 120 volts, that's no joke. So, when you're putting everything back together, just keep in mind, bearing needs to be pressed back in. Usually if you just squeeze it by hand, or it's alright to give a little bit of persuasion. And you can usually use the screws to pull it in the rest of the way. Shit lines up. Put it in the wrong spot. And fuck. Shoot these in quick. Persuader back here. 4-pound engineering hammer is an invaluable tool to have. I always have it within close reach of whatever I'm working on. And this is not lining up properly here. Let's see what's going on. Get it to bite. It's not wanting to. And now we got the gearbox assembly put back on. We're gonna stick the brushes back in. Now, normally there'll be a, I don't know if you could see this. Zoom in, won't fucking focus, but there'll be a little lip worn in here on the brushes where they ride on the commutator. You're gonna wanna make sure that you put them back in so that the pattern, the wear pattern in the brushes matches the curvature of the commutator, which is pretty easy to line up. So put it in that way. Generally the brushes will only go in one way. These brass contacts here are usually slotted in a rectangular form, so you can fit the brushes in just one way. And check to make sure that make a good contact there before you put the cap back on. And this is a general wear item on any power tool that has brushes. They get used a lot. They're going to get replaced a lot. And on your cheaper tools, generally the cheaper the tool, the crappier the brush quality is, and the softer the material. They're going to wear out a lot faster. Of course, on the good power tools, they try to find a good balance between a soft material but one that's going to last a long time, because you'd rather have your brushes wear out than your commutator, because the brushes are cheap, a couple bucks a piece, but to replace the whole armature assembly is pretty much the cost of buying a new tool. So that's why they make the brushes out of a lot softer material. Cheaper to replace. Now we're going to put the switch assembly back in. Like I said, on the newer power tools, generally they kind of just sit in place and then it's held together when you put the clamshell back together. But this actually has screws that hold the switch in place. Here on top you don't see that anymore. But you want to make sure that none of your wires are going to get pinched during reassembly. This has a little cutout there, so that looks like it'll be alright. It sits flat, so we'll go ahead and put that, screw the switch back into place quick. Which is a really nice feature. So basically that's it. As far as diagnosing any problems, generally it's going to be in this area here, from the cord, switch, brushes. There, now that we got her all put back together, give her a go. Whenever you're using power tools, It's always a good idea to use a heavy gauge cord, at least a 14. I think this is a 12, but the bigger the cord, the better. Less resistance, less heat. So, give her a go. Good as new. Good for another 70 years of work and abuse. Thanks for watching.